Welcome back to all of my students. So today I will continue lecture number 22 and it is unit 3. So today we will discuss Green's theorem, Green's lemma and the applications of Green's lemma. We will use Green's lemma to prove different results, correct? And then and finally we will prove Green's theorem. So today it is all about Green's. I told about all the things about the green equivalences, that is L, R, H, D, J, and now we will prove Green's lemma. Let's see what is Green's lemma. The structure of this. Green's lemma. Let S be a semigroup. This is Green's lemma, lemma 2.1. 2.1. Let S be a semigroup and A or B let S comma S dash belongs to S1 be such that AS is equal to B and BS dash is equal to A. Then write translation rho S over LA and rho S dash over LB are mutually R class preserving bijections from LA on to LB and from LB on to LA respectively. So first thing is to understand the problem. So try to understand the problem. Let S be a semigroup and A R B. It means that A and B are related to each other, isn't it? And now let S and S dash belongs to S1 be such that AS is equal to B and BS dash is equal to A, correct? Now what we have to prove? This information we have, correct? That A and B are related to each other and SS dash from S1 such that AS is equal to B and BS dash is equal to A. So what we have to prove? We have to prove the right translation rho S restricted to LA and rho S dash restricted to LB. This is the restricted mapping, correct? Because LA is what? LA is a subset of S, correct? So we can restrict the mapping to the subset of S, isn't it? Because rho S is a mapping from S to S. It is the right translation, correct? We can define like this, for example, X rho S is equal to XS. So S is on the right side. In this way it is right translation, correct? Translation means map. So now we are restricting to the subset of S, that is rho S restricted to rho S over LA, rho S over LV. So now we have to prove that these right translations are mutually R class preserving bijections from LA on to LB and LB on to LA. Means that we have to prove that rho S by LA is a 1-1 onto mapping from LA onto LB, correct? And rho S dash by LB is a 1-1 onto mapping, is a bijective mapping from LB onto LA. And also these two mappings are inverses to each other, correct? that is rho s by LA into rho s dash by LB is identity mapping, and rho s dash by LB into composition rho s by LA is identity map, correct? You know that when F composition G is identity map and G composition F is what? Identity map, then what we say? That F inverse is equal to G and G inverse is equal to F, correct? So in this way, they are inverses of each other, correct? And after that, we have to prove that they are R class preserving, means the element and the image, element and its image both should be R related to each other. This we have to prove. So let's start. Consider the right translation. Consider the right translation rho s from S to S by x rho s is equal to what? X S. S belongs to S. So we consider, see, this is the right translation. Why? Because S is on the right side. So x rho s is equal to x s. This map is well defined map, correct? So this is the map. Now what we have to show that we can restrict it to LA. That is, and we have a mapping from rho s from LA. Rho s LA is a map from LA onto LB. We have to show this, correct? For this, what we do, now for any x belongs to LA, x belonging to LA, correct? See, it is x LA. X belonging to LA means what? LA is what? LA is the equivalence class. LA is equivalence relation. So LA is equivalence class, and it is a subset of S. So when x belongs to LA, it means what? That x and A are related to each other, correct? Now as we know that L is what? Right congruence. So x S L A S, since L is what? Since L is what? Right congruence, correct? So x S is L A S, and A S is what? B. So x S L B, and what is x S? We can write it as xs belongs to LB. It implies that what is xs? Xs means x rho s. So x rho s belongs to LB. So it means that when you take we have taken element from LA and we have shown that its image is going into LB. So here it is meaningful. Rho s by LA and LA onto LB is a meaningful map. We can restrict it. We can restrict it to LA because we have shown that we have taken element from LA and we have shown that its image goes in LB, correct? Similarly, you can write rho s dash by LB is a map from LB onto LA. So now you see, now what we have to do. So basically what we have, LA onto LB, LB onto LA. We have a mapping from rho s from LA, and here it is rho s dash by LB, correct? And from LA onto LB. So what this map is? Rho s dash by LB composition rho s by LA, correct? And basically we don't write like this, we just write like this, rho s by LA into rho s dash by LB. We write like this. Why? Because in this book elements are operating from the left side, isn't it? Not on the right side of the function. It is on the left side of the function. So therefore we have to take rho s by LA before, and after that we have to write rho s dash by LB. Correct? It's understood. So, and also LB to LA, then LA to LB. LB to LA means rho s dash by LB and rho s by LA. Correct? So it is rho s by LA composition rho s dash by LB, and we write in the place of this, we write like this: rho s dash by LB into rho s by L. So in order to show that rho s by LA is a bijective map, rho s dash by LB is a bijective map, what we have to show? We have to show that it is equal to the identity map 1LA, and we have to show that it is equal to the identity map LB. So I will show this, and similarly we can write like this. So if we are able to show that F composition G is identity map and G composition F is identity map, correct? So in this way it is proved that both are mutually bijections, correct? As we have to prove rho s by LA and rho s dash by LB are mutually bijections from LA onto LB and LB onto LA respectively, correct? So let's start how we prove this. Now let's take any x belonging to LA, correct? Then x will be what? UA for some U belonging to S1. Because when x belonging to LA means x and A are related to each other. So x will be equal to UA used from the left side, correct? So now now calculate then x rho s by LA rho s dash by LB. So what is this? When you operate this, it will be what? XS rho s dash by LB. It will be what? XS s dash. Both are right translations, correct? As we know that x rho s we have defined already XS, correct? Similarly, x rho s dash is defined as XS dash. Right translations. So of course XS into rho s dash by LB will be what? XS s dash. Now you see this is what? UA S S dash. Now what is AS? UA into SS dash, so it will be what? UAS is what? UB. And what is BS dash? As we know that BS dash is A, so it is UA. And UA is what? X. So basically what we have proved? We have proved that X rho s, we proved that rho s by LA and rho s dash by LB is identity map, because every element is mapped to itself, correct? So it implies what? It implies that rho s by LA into rho s dash by LB is equal to 1 LA, correct? Similarly we can write rho s dash by LB into rho s dash by LA is equal to 1 LB. 1 LB. So in this way we have proved that both rho s by LA, right translations rho s by LA and rho s dash by LB are mutually bijections from LA onto LB and LB onto LA respectively, correct? We can write So write by yourself. Thus, rho s by LB and rho s are mutually bijections from LA onto LB and LB onto LA respectively. Mutually inverse bijections. Mutually inverse. Drop this word. Just write here. Thus, rho s by LA, rho s dash by LB are mutually inverse bijections from LA onto LB and LB onto LA respectively. Now, what is remaining to prove? It is remaining to prove they are also R class preserving. It means that element and its image are R class preserving. Correct? Element and its image are related to each other. We have to prove this. To show that rho s by LA is R class preserving, take any x belongs to LA. Correct? Then x rho s is equal to xs then you write like this: y is equal to x rho s. You say the image of x is y, say y it is. So basically we have to prove it belongs to, of course, LB, correct? So claim, what is our claim? Claim is XRY. This is our claim, correct? So y is equal to xs, and you are multiplying from the right side to x, you are getting y, isn't it? So now what we have to do now y s dash, calculate y s dash. Y s dash is what? Y s dash is basically y rho s by LB. We can write like this because rho s by LB is the right translation. Rho s dash by LB, rho s dash by LB. Now y can be written as xs rho s dash by LB. It means we can write like this: rho s by LA. Xs is what? X rho s by LA. And see, rho s by LA into rho s dash by LB is what? Identity map. So it maps x to x itself. So we have proved that y s dash is equal to x. So y s dash is equal to x and x is equal to y. Both implies what? X or y. So we have proved that rho s by LA is R class preserving. Similarly, rho s dash by LB is also R class preserving. So in this way, Green's lemma is proved. So write by yourself. Similarly, because we have to be fast, time is less, we have to be fast. So write by yourself that similarly we can prove rho s dash by LB is R class preserving. Now I write the statement of dual of Green's lemma, dual statement of Green's lemma, and left as an assignment for all of you. Lemma 2.2, that as be a semigroup and ALB and ALB let T comma T dash belongs to S1 be such that TA is equal to B and T dash B is equal to A, then the left translations lambda T by RA lambda T dash by RB are mutually inverse L class preserving bijections from RA on to RB and from RB on to RA respectively. So this is the dual statement of Green's lemma. That is, let S be a semigroup and A and B are related to each other. Let T comma T dash belongs to S1 be such that TA is equal to B and T dash B is equal to A. Then the left translations lambda T by RA and lambda T dash by RB are mutually inverse L class preserving bijections from RA onto RB and RB onto RA respectively. So this is, so I left this as an assignment for all of you, and you have to do this assignment in your assignment number 2, correct? Now some now important fact is there based on Green's lemma. Let A or B be such that A is equal to B and BS dash is equal to A